This is part 2 of an entire day that we are doing together with PanGeo. In this training, so this morning from 9 to 10:30, people have experienced how to log in into the PanGeo EOSC deployments and how to use X-Array and the deployments on EOSC. Exactly. Now we will show you how to log into OpenEO, what OpenEO actually is, and yeah, these kind of things. The session this afternoon, this is part 3 then, will show you a bit more into detail how to or elaborate on these 2 parts and what is complementary, what is different, and how to use user-defined functions in OpenEO, and how to do curd chunking in PanGeo. All right. First of all, I wanted to ask you. Let's see. No, perfect. First of all, I wanted to ask you who has not seen an OpenEO presentation in this room. That's very surprising. When I usually ask this question, I see less hands up. So I would ask you to take out your phone really quick and actually scan this QR code. We have a really simple questionnaire. It's like 3 questions long. Will take 5 minutes to do. So we can see what the experience with OpenEO is. I also will open the, sorry. All right, here we go for the slow ones. I'll also open up the forms and you can see exactly. I need to log in. Already 7 answers. Let's see. Oh wow, quite some Python experience already. Yeah. So for the ones who came late, here is a QR code that we ask you to scan with your phone really quick. It's only 3 questions, very basic questions, just to get to know you a little bit and to see what the status is in the audience in knowledge about OpenEO or Jupyter, or did it work? QR code? Fine, yeah, good. We have not many R users in the audience. All right, we have quite some experience here. Most of the people know Python code and use GIS systems. Only some know OpenEO or OpenEO platform yet. I guess that's why you're here. Then most of you are also familiar with raster data and vector data cubes, which OpenEO relies heavily on. It's not as much known. And also a specific library is X-Array Dask, as we showed this morning, is also known quite well. And really interesting to see also in our audience here, the stack specification is also quite known. We also have a specific part introducing stack this afternoon. Also, it is used quite heavily for data access within OpenEO, but also in PanGeo. Okay, most people are not familiar, and the rest we will look at actually this afternoon when we when we finish this entire session. Takes a bit. All right, so for those who don't know OpenEO, most of you are not familiar with it. What is OpenEO? So OpenEO platform is based on the specification of OpenEO, and it provides you an intuitive programming library to process EO data. So you can run actually your Earth observation analysis on our federated infrastructure. Why do you need to do this? And thanks, Alex, for the slide. It's been reused quite some time. So the traditional way how you would analyze Earth observation data is you go to your provider or to ESA Hub, download the data, search for, maybe you're not too happy with the Sentinel-2 Level 2A data, so you download the Level 1C, you pre-process it, you store it on your network drive of your institution, and then you resample it to your target resolution, you cut it to a spatial extent, and so on. And then at step 7, you actually realize, oh, my network storage is full and I need to ask my IT from my institution to provide me another 5 terabytes or so. So actually you as a researcher or as a user, you are more handling the data and pushing it around, downloading it and so on, than to be concerned with your research. And this has been partially solved through the cloud deployments that actually you had. So we saw also some Google Earth Engine users, but you could also use Synergize or Sentinel Hub and go to AWS. Or the Vito cloud or the EODC cloud, and you had direct access to the system, but that didn't resolve that when you changed the system, you changed from Google Earth Engine to Sentinel Hub, then you still needed to adapt your code. And the OpenEO API solved this issue, so you could then, with this Horizon 2020 project that has been finalized around 2.5 years ago, you could then just send your specified Earth observation code to the backend, and it resolved it for you. What OpenEO platform did was basically add in another aggregation layer called the aggregator, and now you don't even need to look for the cloud deployment. You can just send it to the OpenEO platform endpoint, your Earth observation analysis, and then it's basically, scheduled on the correct deployment of OpenEO platform. Also, this allows multi-cloud processing, for instance. I will go more quickly over this because this should be quite known here. As I said already, OpenEO relies deeply on the concepts of data cubes. So basically multi-dimensional arrays. You can resolve these Earth observation or this Earth observation data into these multi-dimensional arrays. And the thing is, any representation of this multi-dimensional arrays is fine, right? So the right representation is fine also with the single bands, but also the left representation is fine. It's just different view onto the data. There are a couple of concepts here that I want to mention. So dimensions, you obviously have an X and Y axis that usually resolves the location of the data. And then you also have a timestamp, as you have seen. And then also the resolution is also a dimension, right? Band dimension is also important for Earth observation data. You can filter on these bands or filter on any dimension actually. So you can filter temporally, you can filter spatially, you can filter by band, exactly. There's also apply dimensions, so you can run an absolute value, you can run kernels, everything that you know basically from any GI software that you are aware of. Most of you use Python, but I guess some of you will also use ArcGIS or QGIS, so you can just simply resolve all these kind of things also in that common language. Exactly, resampling is also possible temporally, spatially. I'm not going to go into details. A main concept of OpenEO is the reduced dimension. So basically, you can collapse any kind of dimension, band dimension, temporal dimension, or spatial dimension with a reducer, so mean, max, and so on. And that will give you a result. Usually that's what people are looking for when dealing with these large data cubes, right? At the end, you want for your publication or something, you want one image or one sequence of images that is a decadal or a 10-day mean or a monthly mean or something like that. That's what usually people are looking for. So also the aggregate spatial, temporal, so similar concept again, you can use any kind of polygon or line or so to actually aggregate. Maybe now a bit deeper into what has been done, and thanks to Milutin, I think he's somewhere in the back here. This has been implemented on OpenEO actually. It's a use case from the community that was implemented already last year. So you could actually look at Sentinel-1 disturbances in a way, and you could actually find out selective logging sites from the Sentinel-1 disturbance values. So basically what you see is that over rainforest you get this 10, 11, 12 decibel usual signal, and as soon as the signal drops, you actually see, okay, this must be logging because this is not the scattering from the rainforest anymore. You can also see that there is a build-up phase again, and you can determine from this how long it takes to rebuild the forest into a secondary forest. Another use case developed by people from northern Italy, from ERP, is river discharge. So you can actually look at these sand benches of rivers, and you can estimate the river discharge from that. And it has been done on several rivers, and it looks actually quite nice. The discharge values fit quite nicely. Also similar to Pangeo, we also have a very active user community. So this is from Paolo, the posts on the river discharge. So if you have any questions, you just go onto the forum and you ask your question there, and then you get a quite speedy reply. Exactly. So what is OpenEO in the end? It's a representation of your Earth observation analysis in a common language. This common language will be shown to you shortly. And this analysis can be defined by any client package. So if we go here to the OpenEO Cloud page, you can actually see that we offer three kinds of clients: a JavaScript client. Oh, sorry. I need to quit the presenter mode. Sorry. So. Yeah, now you should see it. So you have a JavaScript client, a Python client, and an R client. Also, you have interactive development possibilities. So there's a Jupyter Lab available where the Python client is directly available, and there is an editor available. It's like a graphical user interface that will be also shown by Daniel now, right? Yep. Yeah. Perfect. So we will switch over. Are there any questions until now?
Cool. Then also, yeah, good morning from my side. I'm Daniel Tix from Synergize, and yeah, we're also part of the OpenEO platform consortium with our Sentinel Hub backend in the federated infrastructure. And within the next 15 minutes, we are getting a bit more hands-on. I will first show you a bit where you can find yeah, a lot of information to get started. Then a bit more where you can find some information on the client libraries that Benjamin already showed before. And then we will create our first process graph and show our first data using the graphical interface, the web editor that Benjamin also already showed before. And for that part, you then need the login that Benjamin is distributing right now. So the first point where I always direct people that want to know more about the OpenEO platform is our website, where you can get a lot of information. We have a news section where we publish regularly news about new collections, presences during conferences, new developments. Then we have the data collection part. That's a good start for when you want to know which data is actually available. And you see that it's a quite extensive list of, in total, more than 140 data sets. We have the most common Landsat, Sentinel, but also derived products like the Coordinate land cover. And then it's quite easy if you want to know a bit more about one data set to just search for it. And then when you open here, we load directly the metadata about this data set from the backend, and you can see things like the preview, the spatial extent, and also which spectral bands are available for that specific collection. Similar about the predefined processes, so OpenEO and OpenEO platform works a lot around predefined processes that are optimized by the backend to execute in a smooth and cost-efficient manner. And to get to know which processes there are already available predefined, we have also here a list of those processes. In total, it's more than 150, and it ranges from simple mathematical processes where you just add pixel values to each other to more complex processes for training and loading machine learning models. And then also, if you need to contact us or want to reach the forum, you have the chance here. And then a bit more hands-on is our documentation page, where you find some user guides on how to get started with the different libraries, where you get links to the Jupyter Lab environment, to the editor, and where we also have a section where we described the use cases that we did now within the project, where you can see what's actually possible to do within the platform. And I would just invite you to check this out a bit and see what's there available. For the first hands-on part, we are going to use now the web editor. We have on the Getting Started editor section where it's a bit more described what the OpenEO platform editor does. And here you will also see the link, editor.openeo.cloud. So I would ask you now to open this link. And when you do so, you will see the graphical interface of the editor. On the left side here, we have a sidebar where you can see, again, the collections that we have available. It's the same list that I showed you already before. And also the processes. We also then have here the user-defined function runtimes. The user-defined functions are a nice way to submit your custom code that can't be easily or can't be translated into OpenEO language using these predefined processes that we have. So if you need or want to do something that you can't construct using these processes, you have the chance to do this in this UDF functionality. We'll have a specific part for this later still. And then the export file formats, which is a list of file formats in which you can output the data. In the central part here, we have the space where you build your process graph. This can be done with a visual model. You see at the bottom here the distinction between visual model or using some JSON code structure. And for the first example, I thought we just create a very, very basic process graph that just loads collection, loads data, and then saves it. So the most simple way, I just want to download one Sentinel-2 image. To do this, you have to select the collection here. You can either search it in the sidebar or just type the Sentinel-2. And then we use the Sentinel-2 L2A Sentinel Hub. And then you can drag and drop it into the visual model here. And what happens is that we have now a load collection process that uses the Sentinel-2 collection. That now that we loaded the collection, the next step in OpenEO, or the last step and our next step, is to save the result. For this, we can directly use the exported file format section here, and we just drag and drop the geotiff because we want to save the data as a geotiff. Also in this visual view, and now we specify a bit more for the load collection by clicking on this small pen here, what data we actually want, because we don't want to download the whole world. So I thought of just downloading some picture over Vienna, and the one way to do this is just to scroll into Vienna, and then by clicking once you remove the bounding box, and if you click one more time you create a new bounding box. For the date I checked, and the latest Sentinel-2 image over Vienna was actually a few days ago, so we are going to select the 1st of November. Start of the day till 1st of November at the end of the day. And then to get the true color image, we are still specifying the 3 bands we need for this. So we add 3 bands, and then add the band 3, band 4, and band 2, which are the red, green, and blue bands for the Sentinel-2 collection. And then we click submit. And then the last step we have to do is to connect the results that we specified in this load collection with our saves result process. And now when we switch to the code, we can actually see that in this JSON structure, it's a different representation of this process graph that we created by this basic. It's the same. We have a load collection process. It has specified here the spatial extent that we set through the interface before. We have the same temporal extent. We have the bands. And then we have a saves process, save result in the geotiff format, which uses the data as input from our first process, the load collection process. So all of this, exploring the collections, checking the processes, creating this process graph can be done without being logged in. Yeah. Sure. Oh. For those who didn't manage to recreate this now or want to take a look at this later, on the website for the workshop, also in this Getting Started session, I linked the JSON of this. It's not yet updated, so JSON, where you find the same process graph, and you can just download it and then drop and drag it into this window here, or copy the JSON structure into this code section here, and then you will have the same process graph. So all of this can be done without being logged in, but for processing the data now, we need to log in because this goes via your account. So this you can do either via the login at the bottom here, or through the guest and log in here. So I would ask you now to log in using either the account that you created before the workshop or the credentials that Benjamin gave around.
For the credentials that I gave out, you will not end up directly here, but you need to select the EGI SSO option. There's a little EGI SSO signature, and then you type in the username and password that I gave you. For the others, you can use any of your social accounts that you used before, or that you signed up with. Yeah.
How can you visualize JSON as results from this? You showed us quickly.
You have at the bottom here a visual model and code, and there you can just switch between the JSON structure and the visual. Yeah.
Thank you.
Everybody is fine?
Could you show us how you save that data? So how you create that second box with save results? How did that happen?
So you can either just drag and drop directly a geotiff here, then you have the save result process with the geotiff format already pre-selected, and then you just take the data that comes from the load collection and connect it to the save result process. Let's try to, yeah. Now, when you click Run Now, which you can do, we start the synchronous processing, which sends this job directly to the backend, and we get a relative soon result. You see here at the bottom that it's processing, and while this is processing, oh, it's already finished. A bit more what you see at the bottom here. At the bottom here is what we just did. We have this Run Now, which does the synchronous processing, but then also a very big part within the OpenEO platform is the asynchronous processing, which you should use for bigger jobs, for more complex jobs, and also when you want to save your process graph and the results to look at them later. So what this does is you basically create a job on the back end that has a status, and then you can say start this job, and you get notified when the back end finished it, and you will have it saved in your account here to look at it later when you logged in. Now that we run this synchronously, you saw that immediately the result as TIFF got downloaded, and also we see it here in the results on the map. This doesn't look very nice yet because the result isn't scaled properly. So what we need to do is to tell the web editor still on which range the values are. So if you put 0 to 4,000 for each of these and ignore the error because it tries to execute this before I entered all the values, the editor will scale the true color image to this value range, and you will see when I zoom in a bit that we have a nice RGB Sentinel-2 image, which we could manipulate a bit further here, and I think somewhere here at this conference center we are currently. For the end, I wanted to show you one more thing. It's our on-demand preview service where you can directly preview the results of a process graph. To do this, we will add one more process because this scaling that we did before in the editor with the 0 to 4,000, we will implement it now in the process graph. For this, we will use an apply process, which you can find in the list of processes here or just by searching it. And we drag and drop it again into our process graph view here. And the apply process basically allows us to apply a different process on each of the pixels within our pipeline. So as input for this, we use again the Sentinel-2 data, and then by clicking here on process, I get a new window where I now have to specify which process I want to apply on each pixel. And as I said, we want to scale the data to the right output range, so we use this linear scale range, where we put as process parameter, we connect those. And then I checked, and the data ranges from 0 to 0.4, and we want to output it for the on-demand preview in a PNG, which has the value range from 0 to 255. So we scale our data that has a original range from between 0 and 0.4 to 0 and 255. And now the last step is to connect the output of this process with the safe result and still switch the format from GeoTIFF to PNG, because that's what we need for the preview. And then when I go to the web services, where you can create your own web service, we also have the option to interactively now view the results of this process graph that I created with this show on map functionality. Just log out and log in again. Otherwise, the process graph that I just created, you will find it also in this repository that we set up for the workshop. So on the page here, you find the same JSON that we created before. So if I copy this and go back to the editor, yeah, I don't know what's wrong, but I can maybe just... so what should have happened is just that we saw a map, and if we would have zoomed in, we would have gotten directly our image from the WMTS service, and depending on the zoom level, we would have seen a different, the image in a different resolution. Maybe we can show this later, but I would turn over to Valentina now, who would show you how to use the Python client through the Jupyter Lab environment. Thanks.
All right, so what I'm going to show now is a different way of running OpenEO processes with the OpenEO Python client. And we are now again on the OpenEO Cloud website. Maybe I just zoom in a bit for the notebook as well. So what Benjamin already mentioned before is that we have the option to use a Jupyter Lab there, and with the Jupyter Lab you can then just log in with your EGI accounts or with your personal accounts again. You can just make use of the Jupyter Lab that's provided by OpenEO there and run the notebooks. Oh, I'm gonna just zoom in again. So what I want to show are two different examples of running OpenEO process graphs or creating OpenEO process graphs with Python, with the OpenEO Python client in the Jupyter notebooks, and then we briefly look at the results. So the first thing that you need to do when you want to run it in Python is to install the OpenEO Python client by just using, for example, pip install OpenEO. But in the Jupyter Lab, this has already been done before, so we can just use import OpenEO and it will work. And the first thing, you can see, the first thing that we need to do then is connect to OpenEO, to the OpenEO server actually. So we do that by using OpenEO.connect. And then we enter OpenEO.cloud, which is the same link that we used here to access the platform. We can then authenticate by using the connection and just click on Authenticate OIDC. This will automatically connect you with your EGI account. Yeah, you can just try it out later maybe. But it should be really straightforward. If you haven't authenticated before, there's just a URL will appear. You can click on it and you can then log in. So to just do something similar that we have seen in the web editor before, we want to have a closer look at a specific collection and then create a process graph for that specific collection. So the first thing we can do there is to use the describe collection process or function. And the collection that I want to have a closer look at now is the bottom of atmosphere Sentinel-2 data collection that is available within OpenEO. And if we run this cell, we get all the metadata that we need about the bottom of atmosphere Sentinel-2. So this is actually a data set that has been pre-computed from 2015 to 2021. So we just have to keep this in mind if we want to load the collection, that it can only be in this temporal range. And also the spatial extent is here defined over Europe. So then you might also be interested in the different kind of processes that are available to run on this collection. So what can we actually do with the data? And if we then use the list processes function, the list of all the processes shows up again, and this looks really similar to what we saw in the web editor before. So I'm just going to show a quick example. Sorry. So there are really lots of processes available now. The first process that we want to run, and we actually can use the OpenEO Python client to create a process graph then that we will send to the backend later. And the first thing that we do is just run the connection and then use the load collection function that is available there. The first thing that we insert here is the name of the collection that we want to load. Then we define the spatial extent. I have selected a spatial extent over Vienna here as well. And also a temporal extent. Here I picked one for 2020. And I also selected the green, red, and the blue bands here. If you don't insert these, all the bands will be loaded, so it's really similar to what you can do in the web editor. The process that
Is there an option to, if I already have downloaded data, to load it in here as well? Instead of using the web?
So for this example, we will use the BOA Sentinel-2 that is available within the OpenEO platform. So we will now just use the data that is available online, but there are other options to do similar things on your own data as well. But the idea is here is really to create a process graph and then send it to the OpenEO cloud so that when there are large amounts of data, the platform really handles these large amounts of data for you, and you just have to download the results. So you don't have to, if it's really large data, you don't have to download it before and then run the computation on your machine. But this will all be done for you, and you just download the results.
Load result process where you can load the result from a previous process graph.
Okay. I'm just wondering because, I mean, this is really nice that these methods chain together, but if I have my own on-premise, my own cluster, for instance, can I then
But
We will have something about this also in the afternoon tutorial, how
Mhm.
to come to the afternoon. Thanks.
yeah, for this part we really create a process graph first, and then we send it to the aggregator, and we as a user just have to care about the results or manage the results then afterwards. So the process that I want to run now on this collection within this spatial extent and temporal extent is the aggregate temporal period process. I can just apply this with this data dot, and then I add the process that I want to use, which is just similar to what we know from other Python examples. And what we have to specify for the aggregate temporal period process is over which period we want to aggregate the data, and also with which method, so what kind of reducer we want to use. Here I just picked the median to give you an example of that, but you could also use the mean, you could use the minimum, the maximum. You can just use the mathematical processes that are available within OpenEO. So they are also in the list of processes that I showed before. The next thing that we have to do then is to also add the save result process to specify in which format we want to save our data in, and just to be able to download the results in that format afterwards. Of course, we could also add more processes in between, but this is just to show a first basic example here. What I then wanted to display is also the flat graph, the functionality that I added here to the saved data. And what we can see here is a dictionary that actually represents the process graph that has just been created. So it contains the load collection process with all the bands that we specified before, the collection, the spatial extent, and the temporal extent. It contains the next process that will be applied on that one, so the aggregate temporal period, and then the save result one. All the code that we've seen so far is just to create this process graph, but it has not been sent to the platform yet, and this will then happen in the next step, where we say create job and then start job. And what we can see here then is that the status is first that this job is queued, and we also see this nice representation that we already know from the web editor, where the processes are listed like this again, and the process will then be executed on OpenEO platform, and you can just check for the status of it again by looking at the job and displaying it, and after some minutes it will be finished. Once it is finished, we can download the results. Okay, the cell for downloading the results disappeared. I think it's just a bug in the Jupyter lab. Some problem with Git. But what I wanted to briefly show in the end is that you can then download the results to onto your machine, and then just have a quick look at it. And what I did here is, I don't want to go too much into detail on it, but I used a simple tone mapping to combine the green, the red, and the blue band, and to just create some example plots of Vienna. And since I selected the year 2020 before and used the aggregate temporal period over some months, we can now have a brief look at this month. So this would for example, be an image that we created over Vienna for February 2020, another one for July. So I just picked some examples to show, and I also added November here. Should I quickly go through the other notebook as well? Or should we skip that one?
Go for the download.
Ah, yeah, sorry. So this is actually also available in, there it is. This is actually also available on GitHub. And if you want to try it out, you can just clone this repository, the Pangeo OpenEO BiDS'23 GitHub repository. And what I just showed was this notebook. So, oops, I need to update the notebook then. I think I pushed the wrong version. So the code for the download is simply using get results and then run results download files on this, and you can specify a path where you want to download your results into there. Yeah, I'm not sure about, because we're already over the timeline. I think maybe I'll just skip this notebook and we look at the client-side processing now.
No, I think you're doing what BDF notebooks now.
Ja.
Ja.
Sollen wir das Client-Side-Processing dann auch weglassen?
Nee, das war Nachmittag.
Yeah.
Just the satellite data coming from can be
Yeah.
defined
Kommt am
on
Nachmittag?
Ja.
Google Earth Engine.
Yeah, so there are
Weil,
different deployments
Yeah.
of OpenEO.
okay, na dann machen wir jetzt in Jeroen seinen Part.
The project, the Horizon project actually implemented OpenEO on top of Google Earth Engine.
Okay.
So instead of Valentina, if you can go back really quick to the notebook, instead of specifying, if you go up in the notebook really quick, instead of specifying OpenEO as a connection endpoint here, OpenEO Cloud, you can specify basically any endpoint. OpenEO Cloud will just connect to the aggregator, which is the federation of Synergize, Sentinel Hub, Vito, and BiDS'23. And currently, I would say the designated collection that you use will specify most of the time where the process graph will go.
On this website also there are all the endpoints of OpenEO that we are aware of, hub.openeo.org. There you can find all the current implementations that are out there, and also the status and versioning and so on that they have. And from there you can also copy the URL to the service, and all of these can be used basically, and even others. This is just a list that we created where people we know work on it, but there might be other instances that we are not aware of that you can of course also use.
But that are also not federated in the OpenEO platform.
Exactly.
But if I want to work with some collections, which there is no.
Yeah, so we will show you this afternoon how to, this is basically the same question that your colleague asked. There is a different, there is a different process available, what's called load stack, and any kind of stack collection can be loaded then, right? But we will show you this afternoon how this is done. Okay.
Okay. Yeah. Then thanks from my side.
So I am going to go relatively fast. It also leaves a bit less room for actually trying out things interactively yourself. But these training sessions are actually quite heavy for our backends because you have so many people at the same time. So it's actually even better to try it out at home or when you're back and on your own pace. That also spreads a bit the load of everybody instead of everybody doing it at once. By the way, what we now also still had in there, but we will have to skip most of that, is in fact about this loading from other data sets, this loading from stack, and also loading client side, but it is coming back in the afternoon session. And that shows really how to load data from, in this case, planetary computer, and then even doing some of the processing locally, which is very nice for fast and interactive debugging when you do not want to depend on these online platforms, which are very good at scaling out and this large-scale processing, but often take more seconds to execute, even especially for small areas, than when doing it locally. So that's this part, which I'm then mostly skipping now. And we go a little bit into advanced workflows. We have quite a bit of them, quite a lot of examples that we can show, and we just picked out a few. Of course, if you have questions, I can also always try to accommodate and show something else. We put the links in there. Yeah, I will show it when I come to the first example, maybe. So the key thing about when porting your workflow over to OpenEO, and it's kind of the same for Pangeo, is that you have to determine the type of algorithm that you have. Because that will then guide you to a certain mapping of what processes to use in OpenEO, and also often to examples that have the same kind of algorithm type. And what do I mean with that? It's actually some algorithms just work on a single observation, right? Just taking one time step and then maybe one band or multiple bands of your product. That's one algorithm type, and that works on that. And that's easy to scale out because you do not need many observations in time or whatever. It's not very complex, just single pixels is super parallelizable. And that also points you to specific calls in OpenEO that are made for that kind of problem. Another example is much more difficult, is actually a temporal analysis. So taking multiple observations, like a year or multiple years, that you actually get this time series, maybe even with multiple bands, and that you then actually do an analysis over that. That's a different algorithm type, and has different properties in terms of scaling. And in OpenEO, you will then also use another process type. And that is really the basic theoretic stuff behind all of it. So here we'll cover a few examples with different algorithm types. The first one is a rank compositing. Not sure if people are familiar with that concept. The one I have here is a max NDVI composite. Compositing methods are very basic Earth observation algorithms, so to speak, because your optical data has clouds. You know, it's full of gaps. So if you want nice 10 daily or monthly images without gaps, which are better for most algorithms to actually work on, then what you need is compositing. And then there's naive methods, like very simple ones to do it, like take all valid values over a month and take the mean or the median per band independently. But that has some drawbacks because you would be combining pixels of different observations in bands. So you're creating a spectral pattern, so to speak, that may not have occurred in reality. That is the problem with the naive methods, although we still sometimes use them. And what the rank compositing then does is saying, okay, let's compute an NDVI, and in our compositing interval, let's say in the month, we take the observation with the maximum NDVI, and then that's the one we select. So it's a more advanced algorithm, and we show how to do that in OpenEO. Here, this is the GitHub page where you can go. It's the OpenEO community sample. So the main OpenEO repository on GitHub is fairly easy to find. It's this one. And then here you actually have the community examples. And there you'll find quite a lot of examples. For instance, in Python, there's these guys. So that's one to certainly look at your own pace and see which ones are of interest to you. So here I had the rank composite locally checked out. Let's see if I can run some cells. And then I'm going to connect to a backend and as a short thing in between, this example, I'm running it on a different backend. We had a question before, like what backends are out there and so on. So we have OpenEO platform, and this is a relatively new one, the one from the Copernicus data space. It runs where the Copernicus Sentinel data is currently hosted in a cloud, and it runs next to the data. So you have access to the whole archives of Sentinel data, which is, of course, very nice to have. It's fairly new. It's only like 4 or 5 months that we have it, so most people don't know it yet. But it's a public service offered by Copernicus, so quite nice.
You turned off or they turned off the API hub not so long ago, and now everything is stored there?
Yes, that's what they're doing, yeah. And we are hosting mostly the OpenEO part there. The people, of course, responsible for the data, that's different organizations. What else is there to say about this one? That actually we're looking into how to further integrate this with the OpenEO platform. This is also fairly new announcement that, well, we're still figuring out how to do it, right? But that you do not need to have multiple accounts for all these different backends, but that you can also use it as a single platform where you do not have to think too much about, okay, where will my process run or whatnot, right? That you just have the full archive data access with the processing resources, and that just works. But for now, we still use a different URL. The next step is loading Sentinel to L2A. This is the default collection name that we try to keep. For level 2A, that's the official ESA collection, so to speak. And we also try to standardize the band name. It makes your algorithms more portable also, because if the code would be the same, but the collection names are different, then you still have to switch around a lot of stuff. So for this type of collection, it's convenient to also standardize that, and that's what we're doing. Then we have a cloud masking method. I'm not going to explain this one. Sentinel-2 cloud masking is a bit, it's not super easy, unfortunately, because the default classification is not super reliable. So here we do a little bit more masking. Then we actually load the NDVI bands. We apply our cloud mask and compute the NDVI. The nice thing here is that in OpenEO, when you have a mask that you apply and then load other bands, then we can be smart about it and avoid loading all the clouded data, right? We do not want to ever load it because it would actually, loading data takes a lot of time. In most of your processes, the bottleneck is loading the data, and you want to avoid that, so this cloud mask really helps with that. And then we come to the difficult part, so to speak. This is like really a more advanced kind of thing that you can do in OpenEO. We apply something on what we call a neighborhood, which is basically just a kind of multi-dimensional matrix, like a subset of your full data cube. And here we say in the time dimension, we want to work on 1 month. And in the X and Y dimension, we just take 1 pixel, so relatively small. And we do not mention the bands, which means that we want to work on all bands. And then we are going to apply this callback process on it, which is a function which will be applied to each small chunk, potentially in parallel on this compute resources. And here, this is the actual compositing, because you see that we compute the maximum NDVI. We figure out, okay, which one is the max. And then we do a loop. This is the array apply, is the equivalent of a loop in OpenEO. We loop over all our values in the month, and we search for the ones that are equal to our maximum NDVI. And we also still keep the other ones, but we just create a binary mask with zeros or 1. And this mask is then actually our final mask that we can use here. see. I know, here we download it. I can still try to do that. It's our final mask that we will eventually use to load the full data cube. Because then the observations that we do not need in our max NDVI will just be masked out. And then finally, we kind of put all the values in the month together again, and then you have your composite. This is what you'll see. I'm now still doing the download. In the meantime, we can look a bit at our mask that we generate. So you really see that it's kind of binary, right? And this is the thing with max NDVI. You get a lot of this salt and pepper because the NDVI can be kind of anywhere. You do have some observations where no data is used. That's very nice because that means that OpenEO doesn't have to worry about loading any of it. And for some, we will still load individual pixels. And that is actually what's going to happen here. So we load other bands, RGB bands, we mask it, and then to have our final compositing really, because then we just still have observation in multiple months, and then we do aggregate temporal period, which was already shown before, to combine per month. And then you really get your monthly composite all the way at the end. I'm going to scroll through a little bit now, but this is my kind of RGB image here that you'll get out in the end. Let me see if my masking down is still ongoing. It was a bit faster this morning when I tried it, and I think we're now already running so many things at the same time that it's maybe a bit taking a bit longer. Yeah. I can maybe also show, I'm not sure. Oh no, I don't have it here in my editor. I'm just going on to the next example. Let me see, where was I? Close down a few things. Go back to Pangeo. So on to the next example. It's about dynamic land cover. So this is a full end-to-end workflow. At Vito, we create the ESA World Cover Map. And this is the algorithm that we show here is about how to do that dynamically. Like if you have your own sampling points, you can actually train a model, random forest, in OpenEO, and then run it for inference. It's, again, a heavier sample that I'm not going to run in here because it would simply take me too long. But it is actually showing that what we really want OpenEO to be an environment where you can implement your workflow end-to-end. So really the full thing, just where you have the actual map coming out. The other aspect that is shown here is really creating a more dynamic on-demand service. When people create land cover maps, it's always, they have to make trade-offs. And a global map is not as good as one that you have tuned for a specific area sometimes. So this would allow you to use your own sampling points, and that's actually what's going to happen here. So we take Lucas data, we select our own training data set, and then in OpenEO, we're going to compute features. Let me see what I'm going to explain here. And then actually train our, this is the fit class random forest, it's that one, that will actually train random forest. And then the in-between part, because that's the nice part, consists of a few relevant things. It's merging Sentinel-1 and 2 data, so really both data sets. The merging happens, let me see, because we didn't cover that one yet. The merging happens in the merge cubes process. It's a very important one for OpenEO because you can really easy load data from multiple sensors and then just say, hey, merge cubes, this cube with this one, and then add another one. And then you really get this multi-sensor data cube that is the basis for many Earth observation algorithms. You also see the compositing going on here. That's what we covered in the previous example. So I'm skipping that. It's really doing the monthly or 10-daily compositing. This one with a more naive method. The one I showed just now was more advanced. And then computing statistics is a typical thing in classification problems. It's where you take your input time series, like your spectral bands, your VV, VH signal from SAR, and you compute temporal statistics over it, which is just, for instance, here we compute quantiles. This SD is a standard deviation over time. And then T-steps is actually sampling steps in the time series at certain fixed moments throughout the year. And those will actually be the training features for our random forest. Random forest takes a one-dimensional input. It doesn't work on temporal values, so like a two-dimensional wouldn't fit into random forest. And that's why we have to convert the multi-band time series signal into a one-dimensional array of features. And what comes out can really be like 90 to 100 features describing your signal for the full year. And that is what a land cover classification model is then trained on to link all those 100 features to a land cover label. And that's what's going to happen here. This compute statistics function is applied using another nice OpenEO process called apply dimension. So we apply it over the time dimension, and there's something special going on in the sense that it will what it returns will be start in the bands dimension, and afterwards the time dimension is gone. And this is what random forest requires as input. So that's it. I'm the rough outline of it, so to speak. And then you can actually go train your model. And once that is done, you can run a prediction. So there's also a prediction job that you can execute. And here we even, what we do in between is doing a prediction for a few sample points, like sample locations that you have taken, again, from Lucas data, where you know the land cover label, can be in a quite broad area. You ask OpenEO to compute the value only at those points, so it doesn't always have to be full rasters. And then you get your validation data set, because you get predicted labels for points where you have the reference label, and that allows you to compute a confusion matrix like the one shown here. And then if you're happy with the score you're getting there, then you can, and here I think we even computed that, was like a nice 85% accuracy. And then we can actually go and do a prediction over a larger area. This is one that we ran in Belgium. So that's dynamic land cover. I have maybe one more. This one I can do quickly. This is ESA World Water. Not sure if you know it. It was done by DHI CRAS. So it's a real ESA project that ported their workflow to OpenEO. It's basically the type of algorithm here is rule-based classification, and it works on single observations because they want to know changes in water, so the presence of water, at like continuously monitoring them. That, for instance, allows you to monitor the height of a certain basin of water or a lake, if it's going up or down, if it's a variation, or maybe even a flood can be seen like that using remote sensing. It's again loading Sentinel-2 and Sentinel-1 data, so the typical pre-processing workflow that we already showed, also a little bit of compositing. And then it's per observation doing rule-based classification. So they created this nice lookup table where you have different rules depending on the type of area where you are, like deserts, mountains, and then even a bit more. And the functions you see here is, again, it's all expressed as OpenEO mathematical functions. So it just looks like plain Python. This is computing water indicators. And then here you have really the rule-based logic, taking values coming from Sentinel-2, coming from Sentinel-1. You have all of them, and then you have this complex series of if statements where you combine it into a final water classification result. That's basically how a real ESA project, World Water, ported their full algorithm into OpenEO. Good. That's my very quick walkthrough of few of our more advanced workflows. There's still this one I had at the bottom, which is fairly important. There's quite a few more topics. There, the OpenEO platform documentation is also quite good. But what I wanted to highlight is there's, of course, some usage when you use the cloud resources. Not when you do the local client-side processing. It's very nice for that. There you just use your own resources, your laptop. But if you go on the platform, you will see that there's credit usage. And this is nicely shown in batch job results. I can even take one here. Let's see if I have one. And you really see how many credits your job used, and also the CPU usage. This one is what, like if you have a trial account, you get 1,000 credits. So this small job just takes 50 credits, so it's still fine, or it can be even less. Yeah.
What is this approximately in euros?
Last time I checked, but I have to be careful, it was around 1 euro cent. So 50 credits, it's like half a euro or so. So it's not like a huge amounts of money. And actually also these accounts, you can get them via ESA network of resources or even other sponsoring options. So it's actually, we hardly have users that really pay for it out of their own pocket. You can actually get the sponsoring via ESA projects or often also other options. Yeah, I think that's it. We can wrap up here. Yeah, there's a lot to talk about, but let's finish.
Any questions to Jeroen?
How big is was the e-box for whatever you downloaded there? Or how big was the data?
Let me see. That was also actually in the metadata, but now I have to go find it again. Yeah, I don't know anymore on which one I clicked. I think it was one of the small, not super small, a little bit larger maybe. But this one, it was probably like somewhere in the area of 500 by 500 pixels. So in Sentinel-2, that's 5 by 5 kilometer, something. Yeah, yeah.
Thanks a lot, Jeroen, again. That leaves me to wrap up the course. We have 10 more minutes to basically show you where to get funding. Jeroen also mentioned this already before. So basically we have exactly a couple of things here left to say. So I already mentioned the forum. I think Daniel also mentioned it in the very beginning. So if you go to the OpenEO Cloud website, here you can really easily contact us under this email address, or you can go to the forum. Also with your users, you can directly sign in. I think I will be signed in right away now. Exactly, I'm already signed in. basically that's where you can get help. There's a register here button up here. That's where you get your free trial account. So once these users that we handed out are, I will do new passwords next week, so you can still use them throughout the week, but exactly as then you have to register for a free account that will give you 30 days of usage with these 1,000 credits. After that, you can go down here to the service offering, and ESA sponsors currently our project through the network of resources. Anyone, even non-ESA projects, can use this. There's a little outline how to do a network of resources sponsoring. Also, the sponsor, the provider of the network of resources changes. So if you want to do it rather quickly now, or wait till next month, because there's the switch over to the new NOR provider. But up to 5,000 euros, which is a really nice account, I can show you really quickly. You can basically click together, I think, lots of resources. I think we have a package of 100,000 credits that you can click multiple times. So here there's the EODC logo, because we are the lead of the OpenEO platform project, and there's the OpenEO logo next to it. You go to the pricing wizard, and there you can click together basically a basic license would be 100 euros with 10,000 credits a month. There's also the advanced professional available, or the university if you're more people. Then if you're a group at the university wanting to use OpenEO, that's also possible, and then you can see here the extra credits. So if you want to really process something big, then you would take basically a subscription for, I don't know, 6 months, and you click together extra credits here, and then you end up with 4,600 euros, and you can use that for 6 months for your account. Exactly. That's one thing I wanted to show. Exactly. FAQ. This is really important as well. There is a FAQ page that we still need to link, but /FAQ that you can find different authentication errors, or this expiry notification email that you would get yearly because your membership to the EGI virtual organization runs out. Then you just need to re-click the link, and you're good. You can use on your credits and so on. Exactly. Then, as Jeroen mentioned already, there are several OpenEO, or we mentioned it already, there are several OpenEO implementations also listed here under OpenEO Hub. There's one new implementation that is not listed here. It's OpenEO.Copernicus. Help me out. Copernicus.
First one.
Data space. Yeah, it's the space. Sorry, yeah, it's already here. Sorry. Exactly. So there's the data space ecosystem where we plan to merge the users and yeah. So basically, when you open this in the web editor, you get also an OpenEO, but you need to log in with your Copernicus data space ecosystem login. If I click this, then I need to log in with my account instead of my EGI virtual organization. I should have mentioned this. And then from our colleagues from URAC, there is this additional course available. To be available, which will, I don't know how long is it, Alex? How long is the course?
Well, this is a full online course that is supposed. It has 11 different lectures with a lot of different topics in general. It has a lot of different topics in general: introduction to cloud computing, metadata, data in general, how to do parallelization strategies, all kinds of things that you have to consider when working in the cloud, and then there are a lot of examples for how to do data processing. And I think the whole course, if you do everything, takes probably at least 2 days or so. If you really full-time only do this, or maybe even a bit more, it comes together with video lectures and recording and so on. So it's a really like an online course, like the stuff that you find on Coursera or platforms like this. It's supposed to be, and it will probably go online in January. We are, I think, now the first test lecture is online actually this afternoon in the other demo session, the OpenEO session. There's also a demo of this course included by my colleague Peter Zellner, who's the project manager of this. But if you have questions about this, you can also come to us throughout the conference here. There are also the people from Europe, but also from UX and from DLR and others working on this course. So I think it exactly, yeah. And Ignite Education. There's the EO College. This is the platform where we host this. It's actually a nice resource. There's already a number of Earth observation related training courses available for all kinds of different topics, doing just working with optical data, working with radar data, very basic things. And on this platform, we will also launch this course then. Thanks.
Thanks, Alex. Yeah, we are quite on time. Are there any more questions? Any feedback? Anything? Everybody's hungry? All right, then let's have lunch, and thank you very much for joining, and we see you back at 2 o'clock for the joint session.